Hello everyone. My name is Bingyuan Wang, and I'm currently a PhD candidate at the Hong Kong University of Science and Technology, Guangzhou. It's a great pleasure to be here and to have the opportunity to present my work on behalf of my collaborators, Hengyu Meng, Ruwei Cao, Zeyu Tsai, Lanjiong Li, Yu Ma, Qifeng Chen, and Zeyu Wang. I would like to begin by thanking the organizers for this opportunity and all of you for attending this session. I look forward to sharing my findings with you and hopefully engaging in some insightful discussions. The topic I'm going to present today is MagicScroll, enhancing immersive storytelling with controllable scroll image generation. Visual storytelling often uses non-typical aspect ratio images like scroll paintings, comic strips, and cinematic posters to create an expressive and compelling narrative. The applications lie in not only artistic creation, but also poster design and mimicry of some traditional artistic forms. Typically, the goal is to unfold the plot in a spatial sequence, while maintaining the key scenes and objects, to convey events, establish narratives, and create atmosphere. While generative AI has achieved great success and shown the potential to reshape the creative industry, current methods cannot generate images suitable for storytelling. For example, in generating visual mimicries of traditional Chinese painting, previous methods mainly suffer from insufficient content, repetitive object, incoherent visual, and less controllable style and layout. This paper focuses on generating scroll images better fit for visual storytelling scenarios. To overcome the shortcomings, we propose a multi-layered, progressive diffusion-based image generation framework with a novel semantic-aware denoising process. We also design a series of story-inspired visual forms that integrate scroll images and narrative structures to achieve storytelling effects. Our generative framework mainly consists of GPT-based layout prediction, semantic-aware denoising, as well as text-based and image-based style control. From storytelling text, our model supports generating scroll images with style and layout controls. For the GPT-based layout prediction module, we apply instruction tuning to a ChatGPT model to extract bounding boxes of scenes and objects from the story text. We introduced semi-automatic inspection, including GPT-based automatic filtering and optional user confirmation, to ensure that GPT generates a reasonable layout. To enhance the coherence and controllability in generated images, we adopt a multi-diffusion process and design a latent blending and smoothing method to enable fine-grained control over the generated image on both foreground objects, midground scenes, and background styles. Our results demonstrate that latent smoothing can reduce artifacts in the transitional areas between different scenes. On the other hand, blending foreground and midground latents can improve both target object generation and coherence between object and scenes. The style control modules determine the stylistic attributes via encoding the text prompt and reference image. For text-based style control, we add a textual inversion and a compel module to the clip encoder for concept introduction and object augmentation. We also support image-based style control by encoding a reference image and apply Gaussian noise. We also propose a series of story-inspired visual forms that integrate scroll images and narrative structures to achieve storytelling effects. We use multiple sliding windows to denoise over the entire image, enhancing continuity between different regions. We include 4 example ways to extend and expand the sliding window strategy to represent different story organizations. Finally, we establish the first benchmark for scroll image generation for visual storytelling, including mediums like paintings, comics, and cinematic panoramas, with customized metrics for systematic evaluation. Through comparative and ablation studies, our framework showcases promising results in aligning with human perception, improving visual coherence, and engaging the audience, surpassing previous methods in generating scroll images from storytelling texts. From qualitative comparison, we find that our scroll generation framework successfully solves the problems of repetitive content and a lack of controllability in previous methods, and can generate coherent and engaging visuals for different scenarios. We demonstrate the model's capability to mimic styles of specific historical contexts in Chinese painting generation, semantic layout planning and control in comic strip creation, as well as content richness and diversity in cinematic panorama design. Here we illustrate more results combined with other image-to-video tools. Based on a long series of storytelling text, we are able to identify the key scenes and objects, and preserve them in generating coherent and engaging visuals. We can optionally use a post-processing method to animate them. Our model supports precise control by either predicted masks or user-depicted reference images, and can preserve both the color and layout information in the generated results. We also support generating visual storytelling, scroll images in different aspect ratios. We then provide an example to show the effects of visual storytelling on a 2D screen by our model. The story goes on like this. In a serene garden, lakes and waterfalls flow gently as two girls, dressed in long skirts, run through it. The flowing water travels through dense forests, reaching vast meadows covered with green trees. Distant mountain peaks come into view, and amidst the ever-changing clouds, the mountains and waters harmonize. In this fantastical world, we gradually witness a series of towering castles standing in the distant lakeside, narrating an ancient story under the blue sky. Finally, we demonstrate user experience in our VR system. In the VR environment, users can navigate in the virtual exhibition through clicking on the main menu. We mainly include 4 visual forms, including chain, ring, fork, and deformed, and other regular scroll images for comparison. Users can watch multiple effects of each visual form and change their perspectives intuitively. They can also roam freely to explore a same visual from different angles. We mainly include 4 visual forms corresponding to the scroll representation to convey different narrative structures. The chain form represents a traditional linear narrative that can be infinitely extended, emphasizing continuity and flow to establish a classical storytelling rhythm. In our VR environment, this form is presented as a spiral-like long scroll that visually extends infinitely, surrounding the user both horizontally and vertically. The ring form embodies a circular narrative where the end coherently loops back to the beginning, symbolizing structural innovation in narrative design. This form evokes a sense of completion while allowing the story to repeat indefinitely. In VR, it is presented as a closed circular scroll that creates a continuous, all-encompassing environment. The fork form visualizes repetitive phrasing or parallel storylines through branch narratives, where the initial part of the narrative remains the same, but the latter diverges into different outcomes. This approach highlights innovation in rhetorical techniques. In VR, it is displayed with a pair of mirrored images, with the sections closer to the center remaining similar, while the outer areas show variation. The deformed form utilizes irregular shapes, such as folding or warped geometries, to convey special meanings, representing innovation in the medium of exhibition. Drawing inspiration from traditional East Asian art, we incorporate a fan-shaped design that echoes the structure of ancient hand fans in our VR environment. We invited a total of 26 users to participate in an in-depth VR user experiment and focused on 2 series of questions. Compared to watching scroll images on a 2D screen, how was the VR experience from different perspectives? And compared to regular scroll images in VR, how was the storytelling experience with different visual forms? Based on statistical tests, we found that watching scroll images in VR can improve user experience compared to viewing them on a desktop, and scroll-based visual forms can enhance the storytelling experience compared to regular images. In summary, our framework is able to generate controllable, coherent, and engaging scroll images for visual storytelling, which has the potential to be widely applied in the creative industries and media production. There are also many possible future directions to explore. Here, we provide links to the project webpage and a live demo. Please feel free to explore these resources for more details. I would like to thank you again for your attention, and I'm happy to answer any questions you may have. Please don't hesitate to ask about any aspect of the work, or if you have thoughts on potential collaborations or improvements. Thank you once again, and I look forward to hearing your feedback and engaging in more discussions.